All right, welcome back, everybody. This is limits of rational equations, part two. When the degree on top is the same as the degree on the bottom, then we peel off the coefficients out in front, and that is the horizontal asymptote. So this only works as you approach positive or negative infinity. If it's not going to positive or negative infinity, it does not behave like the asymptote. So again, numerical value here, you got to throw it in there and see what happens, just like section 1.2. So this one, peel off the coefficients out in front, it goes to 3/5. This one, as x approaches infinity, remember the lead coefficient is the coefficient in front of the highest power of x. When the power of x, the exponent are the same on the top and the bottom, when the degrees are the same, then you get to peel off the coefficient in front of those. And this one goes to -4/10, which is got to be reduced to -2/5. Okay? Now, let me show you how the book wants you to do these problems. So this is the algebraic approach. The calculus approach is divide everything through by the highest power of x everywhere. So this highest power of x in this problem is x to the first. Take 3x and divide it by x, 4 divided by x, so on and so forth. When you divide everything through by x, let's see what happens. These x's cancel. These x's cancel. And now it's time to reapply the limit. When you let this x go to negative infinity, you have 4 over something that's very, very large, but negative. That goes to 0, okay? So minus a -0, it's gone. When you apply the limit down here to the bottom, 1 over negative infinity, that goes to 0. And you're left with 3/5. Okay? Method number 3. The Smith method. When you take the limit as x approaches negative infinity of 3x minus 4 over 5x plus 1, individual polynomials only behave like the highest power of x as you approach infinity. So this, again, it only works if you approach positive or negative infinity. So the top is going to behave like that. The bottom is going to behave like the highest power of x. So that's inconsequential. The x's cancel, and you're left with 3/5. Let's use the Smith method on this one. If the top is a polynomial and only behaves like the highest power of x, it's only going to behave like that -4x. The bottom is only going to behave like that 10x squared. Those others are inconsequential. The x squareds, they cancel, and you're left with -2/5. I hope this helps, guys. We've got part 3 coming up.